Hey City of STEM, I'm Lisa Winter, and today I'm going to teach you how robots work. If you've ever watched BattleBots on TV, you may have seen me and my robots, or you may have seen me as a judge on the show. Here are some of my robots. There's Doughboy, Tento, Plan X, Mega Tento, and Mini Tento. In BattleBots, 2 robots enter the arena, fight for 3 minutes, and only 1 robot wins. It's a very fun competition. But there are many types of robots besides BattleBots. There are robotic arms for manufacturing that can do things like weld and paint. There are medical robots to help with surgery, cleaning robots like a Roomba, which you may have at home. There are mobile robots to help do things that are difficult for humans to do, like go into radioactive zones or even go to Mars. Robots can be made to do many, many things. So now I'm going to show you how a robot works. It may sound difficult, but I'm going to break down all the components so that they make sense. First, you have your power and your motor, and you want to get the power into the motor to make it run. In order to control how much power you put into the motor, you need a speed control. And this literally controls the speed. Next, you want to add a receiver. The receiver receives the signal from the transmitter. This is what I use to control the robot, and this is what a lot of people use. It's 2 joysticks. I use one for driving and one for my weapons. So when I'm giving directions on the joystick, the receiver will listen to that signal and tell the speed controller exactly how much power to put into the motor. So you can think of this as sort of like a slider where the center is 0 and all the way at the top is 100%. It's also sort of like playing a racing video game. This is sort of like an N64 or PlayStation. So if you ever played Mario Kart, it's very similar to that. This is the same circuit that we just drew. I'm going to take the transmitter and move the joystick. So you can see the motor's running. So the signal's getting picked up here, goes to the speed control, and it's taking the power from the battery and putting it into the motor whenever I tell it to. If you add a second motor to the previous diagram, you get this, which is really the basis for most 2-wheeled robots. And it's super simple. It's the same thing we went over, except it has 2 motors instead of 1. So the one thing you do want to make sure though is that the speed controller you have is a 2-channel speed controller, because you need 1 channel for each of the motors. Let's do a quick review. So I have my transmitter, and I'm pushing the joystick. I'm sending a signal out that's picked up by the receiver. And the receiver is telling this ESC, the electronic speed controller, exactly how much power to give to my motors. So we have the battery as our power source, and it's plugged into the speed control. But nothing is going out to the 2 motors until I tell it what to do. So I'm saying I want to give all the way to the top 100% power to my motor 1 and motor 2, and the speed controller does that for me. This is mini Tento. It's a small version of Tentomushi. If I take the shell off, you can see the electronics, and this is very much like the diagram. We have the 2 motors for driving, and the orange thing here is the receiver, takes in the signal from the transmitter, the batteries, and it's a bit hard to see, but here's the 2-channel speed controller that's speaking to the drive motor 1 and 2. But we also have a second 2-channel speed controller, and that is controlling our spinning weapon and the lifter. Well, thanks for watching. I hope you had fun and learned something from this video. Robotics doesn't need to be hard, it doesn't need to be intimidating, and anyone can do it. So have fun building.